Hi, this is Margo. This is Saturday, May 19th, 2018, and I'm going to bring you another update with methane levels around the world, carbon dioxide levels around the world, and we're going to be focusing some more on the East Siberian Ice Shelf today. There's some activity going on over there. I'm going to show you some of that. So this is my weekly update that I'm going to attempt to keep up with as things start falling apart with abrupt climate change and things like that, just to keep people informed, because I know that everyone has busy lives and most people don't have time to sit around and go to these websites and make the little movies and watch everything in real time, you know, what's going on. So this is a hobby of mine, and so I'm just sharing with people and I'm learning, and so as I go I'm going to be sharing what I'm learning. So, and also just an announcement before we get started in the show today. I will be interviewing Guy McPherson on May the 31st, and this will be my second interview with him. My first interview was done in March of last year, 2017, and if you'd like to listen to that interview, I have the link below. It's on my YouTube channel. And in our show on the 29th, we're going to be focusing on methane. We're really going to be digging into the subject of methane. So if you have any questions for Dr. McPherson, you can put them in the comments below and I'll be happy to ask him. And right now I'm thinking I'm going to make it a live call-in show where people can call in on the phone and participate or just listen, and you can ask questions directly of Dr. McPherson if you so desire. I haven't completely decided on that yet. I'm still up in the air on that. I will not tolerate any trolls or anyone wasting people's time on that call. So if you would like a live call-in show, you know, put that in the comments too, and I'll take all of that into consideration. And you know, he's a teacher and that's what he does, and he's happy to teach and he's happy to help us understand what's going on with abrupt climate change. So enough of that, let's get started. The website I have up is CAMS, it's called CAMS, Copernicus Atmosphere Monitoring Service, and the page that I have up is a page of charts, and I will put the link below. And what I've been doing is going every day to this charts view, and you go to the base time and they update the information from the day before, and then they do forecasts out for 5 days from the latest information. So the latest information is in. It is from yesterday, Friday, May 18th. So that's the base time that we're working from today. So make sure you do that, and then you can save that in your web browser and save it in your bookmarks so you can come back to it. And if you've not seen any of my other methane videos, you can go to those, and in my first one I go into detail about how to use these charts, and that these are 3-hour tick marks down here where they show the updates in 3 hours, and this is UTC time. The scale down here with the colors is methane in parts per billion. That's how it's measured. And the climate scientists are concerned because methane is increasing worldwide. It is a combustible gas. Go to my first methane video. I give a big background on methane and where it comes from. Primarily, it comes from the earth as a result of decaying matter, and the climate scientists are concerned that it's being released in the ocean, specifically in the Arctic, and that it's bubbling up through cracks in the ice, and that there are lots of methane stores, gigatons of methane stored under the sea ice and under the permafrost that's melting, especially on the Eastern Siberian Sea Shelf. And we're going to be looking at that today. And I'm going to be showing you some activity that's going on over there. And I'm also going to be sharing an interview that Nick Breeze did with Natalia Shukova and her partner. Here's the interview that we're going to be looking at, and Dr. Igor Semiletov. They are Russian, and they've gone on these expeditions and done ice core drilling in the permafrost off the shores over here on the Eastern Siberian Ice Shelf, and they're very concerned about the warming temperatures and the methane that's bubbling up. So we're going to do an overview of that, and I'm going to be leaving links to all of that. But it's just to understand a little bit more about really what's going on in the Arctic, because the Arctic is warming a lot faster than the rest of the world, and that's another thing that climate scientists are so concerned about. So this is our view from the Arctic looking down. This is the North Pole. This is Greenland. This is Canada over here, Alaska, United States, and it comes down here, South America. And then here is England, here's Norway, and here's Europe, and this is the top part of Africa down here, and this is all Russia over here, and Siberia and Russia, and then here's India down here, and East Asia, China, and those areas. And you can see the shift. This is like a round view of the globe, and you can see the blue color where it's less methane. It's about at 1760 parts per billion down here in the blue area, and then you can see an abrupt shift to the green, and it goes to this darker green almost immediately, and that's over 1800 parts per billion. It's about 1820 parts per billion, and then when it goes to the lighter green, it's getting higher in methane concentrations. And so as you get closer to the Arctic, you can see that the methane is increasing in higher concentrations to the top of the world overall, and this is what the climate scientists are so concerned about, because methane heats up the atmosphere, and as the atmosphere heats up, then the ocean temperatures heat up, and the ice is melting faster, and glaciers are melting faster, and they're predicting possibly an ice-free Arctic this summer, a blue ocean event. And if that happens, then they're predicting that we will have extreme changes in the weather to where we will not be able to grow crops and harvest them and store them, and that there will begin to be extreme abrupt climate change, climate disruption, and massive starvation and collapse of civilization as we know it, and everything will go like dominoes within the next year. And so that's kind of what the outlook is. That's kind of like worst case scenario. But what they found is, so far, worst case scenario is what they've seen, and it's even worse than worst case scenario of what the predictions were. So let's see what's going on. Let's make our movie. We're starting from yesterday over here, and we're going to click on this arrow, and it's going to load all the data from the last 5 days, from yesterday, and then make the forecast for the next 5 days. This will be through Tuesday, May the 12th, and May the 22nd. I'm off on my dates. May the 22nd. Sorry. And we'll see what's in store. Now, it's been a little bit cooler around the globe, so some of the areas might not look as bad as last week, but we're focusing on the Arctic right now, and I'll get a closer view in a moment, and I've got another interesting view that I found that you can get to on this website too. So you can see everything moving along, and when it really increases, that's when the sun is shining on that part of the world, and then when it goes down, that's nighttime. So when it's increased a lot on the right side, that's the sun shining on that side of the world, and when it increases on the left side, that's the sun shining on that side of the world, and then it goes down on the other side. So that's a very non-academic explanation, but it's interesting. It's really picking up. You can see that it's picking up. Look at Norway. It's popping up off the coast of Norway, like we saw last week, and it's popping up still near this little island, and of course my browser would crash. I'm going to pause the recording. Okay, I've restored the browser. I get lots of interference when I'm making these videos. You would not believe the trouble that I go through, all the problems that I have. I get interfered with so much electronically with uploading and saving and making the videos, and I get strange phone calls and hang-up calls, and it's they're interested. I think so. Someone's interested. So we're doing the movie again. And so here's the little island off the coast that some of the climate scientists have been really watching. Paul Beckwith has been watching that area. I forget what it's called. I cannot remember the names of all these things. So I've got a map of Russia up here. Let's look at that real quick. Okay, this is the island that we're talking about. Novaya Zemlya. Novaya Zemlya. Okay, we'll go back to the movie going. Here's Novaya Zemlya, and this is Siberia up here. You can see where all this red is coming up. This is about it's over 2,000 parts per billion 2040, and where it gets really, really, really dark red, it's 75,600 parts per billion. It almost looks black. You've got that over in India and parts of China and parts of Asia, and parts of all the countries have that really black area too. And it's popping up. These darker reds are popping up over here. This is part of Eastern Siberia that they're worried about. So I'm going to pause that. And now I'm going to shift the view, the area, and you can shift the area by going up here. And now we're going to get a closer view on the Arctic area. Here we go. And if you want to get even closer in, you can go Control and the plus sign on your keyboard, and it'll increase the screen. I just did it 3 times. And it moved everything down because it's a big, larger view. So I think it'd be interesting to make our movie at this view. So let's run it now. Let's go back to the beginning of our time frame, which was yesterday, Friday. Here it was at 3 UTC. Yes, yesterday, Friday. And now it's going to load the movie. Here we go. Has to load it up. You can see the progress down here in loading it up. Okay, here it goes. Wow. Okay, here's that little island, Novaya Zemlya, and you can see it coming up here, and this is ice covered and snow covered over here. So it's coming up through the cracks in the ice is what the climate scientists think. Now look at it's popping up off the shore of Norway too. It's not as bad as it had been last week, but it's still coming up. You can see it's still coming up here. And we talked about the trailing effect, where after it comes up, if you see it like a tail, usually it goes into the lighter colors as it starts trailing and moving with the wind. But this is at surface level. So when you get on here, make sure that you've clicked on surface. This is surface level. Usually it's might not be right at ground level, but within 2 meters, which is about 6 feet above the ground. So that's still very close to the ground, to that surface level. So that's, and you can see it also coming up on the shorelines, and that's what the climate scientists are worried about too, because as it's melting, there are sediments on all these shorelines that are melting and coming up through as the permafrost melts, the methane is coming out. Now this is part of the Eastern Siberian ice shelf right over here, and this is becoming active, and this is part of the area that Natalia Shukova and the others are really watching that there's huge methane stored over here. And this Eastern Siberian ice shelf is shallow, and that's another reason they're concerned, because it's not very deep, and so it's going to melt quicker than other parts of the Arctic Ocean. And then you can see Alaska, and it's got a lot of permafrost and it's rocking along, and you can see over here coming up out of the ocean, you can see it all along the edges, and here this is still Siberia over here. So that's what we've got going on the Arctic view. I'm going to go back to the normal view. I'm going to hit Control and minus 3 times and go back to my normal view. And I'd like to share some maps with you right now so that we get a better idea of what we're looking at. This is a larger map of northern Russia, and we're looking at this northern area. Here's Novaya Zemlya, which was that little island where the methane was popping up here. Here's the Kara Sea. Here's the Laptev Sea, and this is the East Siberian Sea, and here's the Chukchi Sea. And these are all the seas from the Arctic that are connected on the edge of the Arctic Ocean that the climate scientists are all watching. And this Eastern Siberian ice shelf covers this whole area here. And I've got another map I want to show you that really outlines that. It's in this article. It's this interview that Nick Breeze did, and he shows you exactly. Here it is. This is the East Siberian ice shelf. It covers quite a large area. And okay, so here's the Kara Sea, there's the Barents Sea, there's Novaya Zemlya, and then there are these little islands over here, and then the ice shelf starts where it juts out. That this is the whole area that they're concerned about. So let's go back to our view. So here's those little islands. So it's from here all the way over. So it's all of the coastline and this whole area that we're looking at. And that's the area that we're going to look at for methane activity, because when you see that red popping up, that means that the methane is coming up through these frozen areas. This is still frozen up here. So it's coming up through the cracks in the ice. So I'm going to share another view with you. Now this is another view on cams. What you do, you go to the home page, okay, you go there. I'm gonna go back so that I can keep my other view up. But once you go there, then you can go and find all this information yourself. You hit enter under catalog, and you put in your filters, and it saves them. It saves your filters from the last time that you were here, and you can go to product family, and I put in global forecasts. I checked those, and I clicked Under the parameter family, I clicked aerosol, greenhouse gas, radiation, and reactive gas, and then I clicked carbon dioxide and methane underneath parameters, and these are the reports or the views that can come up. Okay, so we're going to go to global forecast for greenhouse gases methane. We're going to let that load. Why is that not working? See, I'm being interfered with. I know I am. This was working earlier. Being blocked. It'll work for you, probably, but it's not working for me because I was going to share this data with you today. So, we can't look at that right now. But that's what you can do. And next time, or when I'm not trying to make a show, I will record it and then I'll make a show out of it. But you'll get a whole different view that's really interesting. So, this is frustrating. See, this just is not working. It's not going there. But at least my charts are working. So, let's go back. Since that's not going to work. Let's go to the globe area. This is the whole globe. And we can see it here. It's just that it's not as big of a view as what I would have gotten on the other one. It's the same view though, but that's okay. Let's go. I'm going to increase this. Plus, plus, plus. I'm going to do it 3 times so I can get as big a view as possible. And let's make the movie. Okay, it's got to load up. And this is going to be interesting to see the methane levels worldwide. Okay, here it goes. I don't know why it's jumping up and down like that. That's annoying. It just has to, maybe it just has to smooth out. Okay. Here's Novaya Zemlya. Here, you can see that. You can see the red on both sides of that island popping up. And now here is the East Siberian area. Look at that. You can see it coming right on the coastline where those sediments are coming up, where it's starting to melt. Look, and that's what the climate scientists are so worried about. See, it's right on the coast. It's a whole area that's just, it's like, it goes into that really dark red. So that's heating up and melting a lot faster, it looks like. And then you've got Alaska over here that you can see. And there's no ice in the Bering Sea, the Bering Strait. There's no ice. That's all melted. And it melted a lot sooner this year. Look, look at that right off the coast of Alaska. And then, of course, you can see all of Canada gets covered up, or a lot of Canada, because they've got lots of permafrost. And then also, where you have a lot of vegetation or lakes, you'll see a lot of methane coming up. Now, South America, here's up here, it's not as bad as last week. And my theory is because we're moving towards summer for the northern hemisphere, and so the southern hemisphere is tilting away from the sun and it's going into its cooler time of year. So I think that's why it's calming down for the southern hemisphere. But of course the northern hemisphere is going to be getting warmer, and so we're going to be getting more methane release as well. And also, now look again. Look at the blue range. This is like in the 1700s for methane down here in the southern hemisphere. The equator is right along here. Right along here is the equator. Okay. And you've got 1700s below that, and then almost immediately it jumps into the green, which are the higher levels of the methane for the whole northern hemisphere. So there's that. I'm going to pause that. And while we're on the world view, I'm going to change my filter, and let's look at carbon dioxide. It's going to load up. Look at that. This is global carbon dioxide. Let's go back to the beginning baseline time. Here's your chart down here to show the levels of the carbon dioxide in the atmosphere. And this is column. It measures in the columns here. Where's my level? Total column. If you click on surface, it looks totally different. See, it's really concentrated on the surface areas. Look at that. Let's go back to total column. And here's the scale, and carbon dioxide is measured in parts per million. Methane is measured in parts per billion. So there's a difference there. And you can see overall, well, down lower you see a little bit of blue-green. So you have more, like the further south you go, you have less carbon dioxide. So overall, it's about 404 parts per million down in the south, and then it starts getting higher the more you come up towards the equator. Here it is with the yellow. That's about 408. And then look at the dramatic shift once you get up here past the equator. And you go into this orange area about, okay, here's 410, 11, 12. So the whole northern hemisphere is almost at 412 parts per million. You have a few areas where it's a little lighter, just depending. And you have lots of areas where it's darker. Look at across Africa and across India. And and then of course it's high up in the Arctic. So let's make this movie. Let's see how it goes. And I was doing some research on all of the different gases that are released with volcanic activity. And I got interested in that because of the volcanic activity that's going on in Hawaii right now. And methane is one of the gases that's released. But more than that is carbon dioxide and sulfur dioxide that are released, and water vapor when you have volcanic eruptions. So one of the reasons I think that the carbon dioxide levels have gone up at the Hawaii stations this week is because of the volcanic eruptions over there. So you can see the carbon dioxide moving slowly, drifting across the ocean, you know, from the lands. It's drifting across and up into the upper atmospheres and upper levels. And this is depending on how the wind goes and the jet stream and ocean currents and things like that. So I'm going to pause that. I'm going to go back to my normal view and go back to my filter, and you can check out all of these other filters. Like if you want to see sulfur dioxide, you can load that up. I've not done this. There's sulfur dioxide. Wow, look at it. This is the Hawaii area. So that's really high. Obviously, you know, coming off of Hawaii. Let's run this movie. I've not done this one before. Wow, look at that. This was at the beginning of yesterday. Let's run this. This is interesting. So you can see how all the different things with these cataclysms and natural disasters and stuff release different kinds of toxic and noxious gases and particulates and things in the atmosphere that stay up in the atmosphere and they end up affecting the whole globe. It doesn't go away. Okay, look. Here's the Hawaii area. Look at that. Wow, you can see it spreading and coming across. And then here's new starting. Whoa, look at that. That was probably during an eruption. Yeah, that was at the beginning of yesterday. And then this is forecasts over here. You know what we could do? Let's go back. Now that we're on sulfur dioxide, let's go back to Tuesday. These are actual, this is actual data back from Tuesday. Level is total column. We'll leave it at total column. Wow, look how high it is up here. And we'll go back. Now this is back to Tuesday. And let's make our movie. So this is usually using actual data through Tuesday, Wednesday, Thursday, Friday, and it's actually only forecasting into Saturday now. So this should be interesting. And I'm going to do a separate show where I talk about volcanic gases and the different kinds of noxious gases that come out of volcanoes when they erupt and how they disperse in the atmosphere and things like that. I'm researching that right now. Look, here's Hawaii. Look, you can see that. Wow, you can see where the eruptions are when those happen. There's a lot down here in Central America. This is sulfur dioxide, and a lot up at the pole. And it's heavier than air, so wow. Look at it up here on Siberia, and look, it's drifting up. This is very interesting. See? That was a really high area on Tuesday. I'm going to pause that. I'm going to shift and go to the Pacific. See if I can get a better view of Hawaii. Okay, here's the Hawaiian areas for sulfur dioxide. See if I can zoom in as much as I can. Okay. Okay, let's go back to Tuesday. Alright, there's Hawaii. Now, here we go. We're going to make our movie. And if people don't like me clearing my throat, it's too bad. I have allergies. I had some nasty comment that I just deleted. The guy said, "Great video, but your coughing is very annoying." You know, it's like, get a life. I just don't need crap like that. The trolls are everywhere. And if people leave comments like that, they're not going to be approved. That is not helpful. You know, they can do the video. Okay, here we go. Look. There's a lot down here, too, in Indonesia. Look at Central America. Sulfur dioxide. There, wonder if that's from, there's a lot of volcanoes down by Costa Rica, in Costa Rica. I wonder if that's from that area. Okay, we're starting back over Tuesday. Anyway, this is interesting. So you can go to this website. I'll leave the links below, and you can do your own experimentation and exploration and learn about what's going on in our atmosphere. It's really interesting. And this is what is affecting all of us. And the more we understand, the more we know what's going on, the more aware, the more educated we are, and the better prepared we'll be emotionally, mentally, spiritually for the things that are coming down. Okay, I'm going to pause that. Now, I'm going to go to this Nick Breeze interview, and we're going to learn some more about the East Siberian Ice Shelf. And I'm going to leave the link below. He did this interview last year. This was published on June 24th, 2017 on Envisionation, Communicating Climate. Interviews and articles by Nick Breeze. It's called Subsea Permafrost on East Siberian Ice Shelf in Accelerated Decline. Interview by Nick Breeze with Dr. Natalia Shakova and Dr. Igor Semiletov. And their original findings were published in Nature Communication Journal. And when you click on that link, it takes you over to their original findings, and it's right here if you want to read all of that. But his interview is very good. It kind of boils everything down to the most important areas, or the most crucial areas that and summarizes it a lot better. Okay. So again, we talked about this whole area being the East Siberian Ice Shelf, or ESAS, East Siberian Arctic Shelf. I've seen it Arctic Shelf and Ice Shelf, so it might be ESIS or ESAS. It's the same thing, I think. I could be wrong. If you're a climate scientist and I'm wrong, you can let me know. And here's a video that they put in here to show the methane bubbles coming up. Oh, I'm turning off the sound so I don't get a copyright strike on that. These are the methane bubbles coming up. It's happening. It's happening. Look at all those. They're really going up fast. Okay, I'm going to pause that. It says gas migration paths building and degrading permafrost acts like a champagne cork. Dr. Shakova, we use an analogy where we compare the East Siberian Arctic Shelf to a bottle of champagne. So the gas produces within this bottle, and it keeps accumulating as long as the cork serves as an impermeable lid. This lid is subsea permafrost. Before it was just permafrost on land, but after it was submerged, it became subsea permafrost and served to preserve. And see, they crashed the tab. This is what happens all the time. Where was I? Here I am. Before it was just permafrost on land, but after it was submerged, it became subsea permafrost and served to preserve an increasing amount of gas produced from its release to the ocean and atmosphere above. While this lid is impermeable, there's nothing to worry about. But when this lid loses its integrity, this is when we start worrying. This is where the methane is releasing, and the amounts of methane currently releasing makes us think it will increase as a result of the disintegration of this permafrost body. And then they go on talking about the permafrost and how it's being melted and released, and between the ice ages and this and that. So you can read this whole interview. It's really good. And then she's worried about a sudden burst of methane once enough of the ice is melted, and then the methane releases. And Nick Bree says, does a sudden burst of methane become feasible as the subsea permafrost is destabilized? And Dr. Shikova says the difference between emissions in background areas and hotspots is orders of magnitude. And then she goes into all of that and saying gas in the areas of hotspots is releasing from the seabed deposits in which free gas has accumulated for hundreds of thousands or even for 1 million years. This is why the amount of this gas and its power is releasing due to its high pressure, and it's tremendous. That would allow large releases of methane, and whatever you call it, outburst, bomb, or whatever. I see no point to say no to such a possibility. I'm afraid to say yes because we still have to learn so much about the mechanism. But she didn't say no. And he says, in relation to the ESAS, how do you know these hydrates are there and that they are a potential threat? And she says the importance of hydrates' involvement in methane emissions is overestimated. The hydrate is just one form of possible reservoirs in which preformed methane could be preserved in the seabed if there are proper pressure or temperature conditions. It is just the layer of hydrates composes just few hundred of meters. This is a very small fraction compared to thousands of meters of underlying gas-charged sediments in the ESAS. Anyway, it goes on and on. And then she says, as gas within the sedimentary basins of the ESAS had been accumulating for 1 million years with no way to be released earlier, the supply for currently occurring emissions is tremendous. Because the shelf area is very shallow, a mean depth is less than 50 meters. A fraction of these emissions will reach the atmosphere. The problem is that when this fraction would be enough to alter the climate on our planet drastically. And then it says they're beginning new work in this area. So I encourage you to go to that website and see what's going on. And so let's wrap it up. Let's look at Climate Reanalyzer. Let's look at today's weather maps and see the temperatures. Today is Saturday, May 19th, 2018, and they measure at 2 meters above the surface. And there are our temperatures for today. This is in Celsius. And let's go to those are your temperature anomalies. Look at this dark area in the Arctic. Let's look at the clouds. Here are your clouds. Uh-oh. Keep my mouse over there. Wind speeds, precipitation, and clouds. Let's look at snow and sea ice cover. Wow. Here's Greenland. This is ice. You see it's retreating. Here's Novaya Zemlya. And you can see the ice is melting here. Here's Alaska. That's really retreated a lot there. And here's that Eastern Siberian ice shelf over here. That's still ice, but you can see the blue is encroaching. The blue is starting to encroach on all of those areas. So I hope you enjoyed our show for today. My name is Margo. I'm a hypnotist, holistic life coach, empathic spiritual healer. My website is margoshealingcorner.com. And I believe our time is short. And I encourage everyone to get your spiritual house in order, whatever spiritual beliefs you have. I do believe time is short. And until next time, take care, God bless, and go in peace. Goodbye.